Josh Wednesday next week?
Yeah, next week. Vince is gonna come Monday or Wednesday.
But he is?
Yeah,
Talk about
for
it?
financial math, yeah. He just got back to me.
I actually want to hear why he decided to become Catholic.
Hey, he would love to take care of things and talk about it. Okay.
Why would he become-
So what we know is that lines, you know, if whatever, you have two lines here. We know that the lines, if they're perpendicular, what do we know about the slopes? Slopes are not equal. Opposite reciprocal. So if the lines are parallel, like this line, then you know that the slopes are equal if the lines are parallel. Yeah. So when we talk about perpendicular vectors, you know, when we talk about vectors, we do talk about a direction, which essentially is a slope. And so if you have the slopes equaling, multiplied together to equal -1, then you know the perpendicular because opposite reciprocals, right? If you have 2/3 as a slope and then -3/2 as a slope, when you multiply those together, their slopes will equal -1. So if your slopes, or if you think of it as like your direction multiplied together give you a -1, then you know you have something that's perpendicular. If they're the same, like 2/3 and 2/3, then you know that they would be parallel. Perpendicular vectors, there's a word, orthogonal. What a new word, right? Orthogonal, that means perpendicular. So it's a word you might see, it's like, it's a mathy word that means perpendicular. So vectors that are perpendicular are sometimes called orthogonal. Useful in knowing for just a brief window of time, meaning, hey, if you have something, an orthogonal vector, you're like, what? Oh yeah, perpendicular vector. So worth knowing. Might, you know, if you have a discussion in another math class about vectors, they might use that word, orthogonal. Other word they use for perpendicular lines or something that is the normal to a curve, and that means something that's perpendicular to a curve, the normal, which is interesting too. They're different words. So, but orthogonal means perpendicular. Dot product. So the dot product is not it's a special type of, if you will, multiplication. So if you have vector V1, they say, I'm just going to write the definition that they have so it is the match. Dot product isn't hard, it's just memorizing what it is. So x2, y2. So if you have vectors x1, y1, and then vector x2, y2. Now when we state that the vector is x1, y1, we can think of that as like this, right? If you have, like this is vector 1, it has a direction and then it has a magnitude if like this point up here is x1, y1. So even though you see it as a coordinate point, you know, like 5, 6, let's say, that would tell you it's coming from the origin, it's going over 5, up 6, you know, if I'm making up the numbers for us. That's giving us the direction that it's going. You can find the angle measure there, and then it's telling us, we can find the magnitude of it like that. So it has a magnitude and it has a direction. So when you see a vector like that, we've talked about that, that's meaning it's just coming, like it's coming from the origin, going that amount out. So if you have two vectors like that, the dot product is, if we say v1 dot v2, so it's kind of like a multiplication of it. All you do is you take x1, x2 multiplied together, and then you add that to y1, y2. So what you actually get out is a specific value. You do not get out a component form. You're not going to get like an x and a y, like a vector. You're not going to get a coordinate point out with dot product. With dot product, you get out one value because you're going to add those together. So you multiply your x's, add it to multiplying the y's. Then there is an equation. I probably would give this to you on the test because it's a unique equation. If you want to find the angle between two vectors, you use this concept of dot product. And here's the equation, cosine of theta, and then like this, and then like this. Okay. if you want to find the angle between two vectors. So to find that, you would go u dot v, which means dot product. So we see we use that little formula, it gives the value. And then what is absolute value, absolute value u, absolute value v, what is that referring to? The magnitude, right? So you just find the magnitude of u, magnitude of v, and then you have the cosine of theta. So if that's on the test, if there's one on the test, I'll give you that little formula so you don't have to memorize it, you just have to know how to use it. So, yeah.
On the test, I kind of like blanked on like the magnitude of one thing.
The magnitude of one.
Like like how to figure out the magnitude of u and the magnitude of v.
Oh, was it the u plus 1/2 w?
Yeah.
The magnitude of u and the magnitude of v.
Yes.
Okay. Well, let's do the magnitude. So let's do something like that. I'll use this. Find the angle measure between. So if you have two vectors and you have u is equal to 3, negative 4, and you have v equal to 3, 4. So these are two vectors. Again, you see it as a coordinate point. The coordinate point is representation of a vector. So what they're stating is it's coming from the origin, right? Over 3 down 4. So here's your vector u, comes out like that. That's vector u. And then vector v would be over 3 up 4, 1, 2, 3, 4, like that. There's vector v like that, okay? There, so over 3 down 4, over 3 up 4, there's vector v. So if you want to find the angle measure in between these two vectors, theta, right? Want to find theta. You're gonna, and this we can find the magnitude and stuff.
So it just comes from the origin.
Yeah, if it's this, we just assume it's coming from the origin.
Okay.
If you have a vector, you know, we talked about that. If you have vector AB, let's say, and vector AB, then that would be referring to that it's not coming from the origin.
Okay.
It would be like here and then here, and it's going
But
up
if
that
it's
direction.
just one, it always.
If you just see this and it's a vector, then yeah, it's going to be coming from the origin.
So then, if you're gonna try to find the magnitude, it's just the square root of 3 squared.
3 squared is 4 squared, right? Because it's 3 minus 0, negative 4 minus 0.
Yeah. Okay.
So it's just 3 squared, negative 4 squared.
All right.
Yep, so it's really easy when it's that. You know, just to finish it off, you know, if this was, you know, 2, 3, and this is whatever, over 6 up 7, like that. If you wanted to find the magnitude of AB, then you have to do the distance formula. You know, so 6 minus 2, 7 minus 3, square both of those.
So then, like A plus B magnitude, like the magnitude of A plus B.
A plus B. That would probably be when you have like vector A and then vector B like that,
Yeah.
and then you're doing like the A plus B type thing. Or
But it's like, how do you do the magnitude of that?
you would have to find, if this is A, this is B, you'd have to find like the component form. But I don't know if we had A plus B like that.
There's like A plus, or like A plus 1/2 B magnitude.
Oh, A plus 1/2 B.
And then it's like.
They told you vector A was something, they told you
Yeah.
vector B was something,
Yeah.
and then they wanted you to find 1/2 A plus B.
No, it's like A plus 1/2 B.
Oh, A plus 1/2 B,
Yeah.
like that.
Yeah.
Well, yeah, you just take half of whatever B is and add it to A, and you can add vectors together. So if you're going to add these vectors together, you have 3 plus 3 is 6, maybe 4 plus 4 is 0. Or if it's 1/2 of B, well this is V, but if you use 1/2, it would be 1.5 and 2.
Yeah.
And then add them together and then do the absolute value, or not the absolute value, do the magnitude, which is
Okay, I think I got
the magnitude again of just two things is coming from the origin, so it's square root of this square plus this square.
it.
Direction.
Yeah. Yeah, me too.
So-
Ruger.
I forgot on 2 vectors.
Okay, so this, we just go cosine of theta is equal to u dot v, so dot product. Remember, dot product doesn't, when you're doing this, the dot product doesn't give you a coordinate, doesn't give you 5, 7 or something like that. It's going to give you a value. So when we do it, it's our x's multiplied together, right? 3 times 3 plus our y's multiplied together, negative 4 times 4, over the magnitude of u, so this is what Nick was talking about, so 3 squared plus a negative 4 squared, times, right? They don't write you don't want to, if you write the dot in between there, people might think of it as dot product, so that's why we write this. So again, dot product, you see up here, that dot means, yeah, you're multiplying the vectors together, but it's a dot product, so you're adding the x's multiplied together to the y's multiplied together, but with here, down here, it's just your magnitude times your magnitude. So we'll put parentheses, and then the square root of 3 squared plus 4 squared. And so then you end up with cosine of theta is equal to, what do you get on the top? 9 plus a negative 16, so you get out a
106.26 degrees.
negative 5,
Oh,
or negative 7.
yeah, negative
7 over
25.
25, because that happens to be the same thing, right? 5, or 25 and 25, so you get out 5 and 5, so then you do inverse cosine, and you end up with what?
106.26.
106.26, seems reasonable based off of the picture that you could have 106.26. You know, just looking at our sketch, it's like, yeah, okay, that could be 160 degrees, 106 degrees, sounds good.
I have one question.
Yeah.
So, it's Pepper saying V1 times by V2. It says V1 times by V2 is equal to X1, X2. Are you adding, subtracting, multiplying, or what's that?
And well, x1, x2, that's multiplying.
Okay.
Yeah, if it was adding, we'd put a plus symbol in between. You know. For that, yeah. Okay, so find A if vectors 4, 6, and A3 are parallel, and then B perpendicular. So you have two vectors, 4, 6, and A3, and you want to find out what A is. If, so two different things going on. First, they're parallel, and then second, they're perpendicular. Okay. So what they're referring to here is if they are parallel, they have the same slope. Slope is found by rise over run, or in terms of x and y, what is slope found by? Y over x, right? And so in this case, we just take the slope of the vector, 6 over 4 means equals 3 over a. What does a need to be? 2. And you could just, 6a is equal to 12, and a would be equal to 2. So if they're parallel, a would equal 2. And then for part B, if they're perpendicular,
Flop it, put a negative.
flop it. Yeah, just flop it. So what we know is that you can think of it two different ways. Yeah, you can flop it and put a negative, so 6 over 4 is equal to a negative a over 3. Is that what you're referring to?
Yeah.
They're opposite reciprocals of each other. So you flip them and then make it a negative. So you get, 4a is equal to a negative 18. And then a is equal to a negative 4.5. Okay. That's one way you can look at it. The other way, which is the same concept, is you could say that when you multiply them together times 3 over a, they should equal a negative 1, which is going to be the same thing that we just did. So however you want to look at it. The book kind of shows this method where they say, multiply your slopes together, they'll equal a -1, and if you solve for A here, you'll get out -4.5. Or, like Nick said, flop them and put a negative, which I like that, flop them. Okay, so I think we're good there. I'm gonna finish grading your mid-chapter assessments right now, and then get them back to you here. I just have a couple more problems to grade on each one. Then we'll get them back to you. I don't know, we'll find out here shortly. Riley got hers back.
Did she do good?